Diagnosing University Students' Academic Writing in English. Is cognitive diagnostic modeling the way forward? Correct diagnosis of students' strengths and weaknesses is important for teachers to understand the diverse learning needs in their classrooms. However, in the realm of writing assessment, two widely used rating methods, holistic and analytic rubrics, are deemed inadequate for diagnostic purposes. Therefore, researchers developed diagnostic checklists to diagnose the problems in students' writing. A diagnostic checklist can break down the writing performance into a wide range of fine-grained descriptors related to multiple aspects of writing, allowing systematic modeling and diagnosis. In this study, the researcher utilized a fine-grained diagnostic checklist to diagnose the English academic writing of first-year undergraduates in Hong Kong. The research adopted cognitive diagnostic modeling, a recent advance in psychometric modeling, to validate the instrument and build diagnostic profiles for students. Cognitive diagnostic modeling belongs to the family of multidimensional item response theory models. This modeling approach recognizes that successful performance on a language task involves the mastery and implementation of multiple subskills. Within the CDM family, there are different models, each has a different assumption about the relationship among the latent skills. For instance, DINA and NINA models, the reparameterized unified model or the fusion model, and the GDINA model. The present study adopted the reduced RUM model. The reduced RUM model specifies the probability of a correct response depends on a student's ability and an item's difficulty and power. P stands for the probability of a correct response. Alpha stands for a student's ability. Pi and R represent item difficulty and item power, respectively, and Q, which stands for the Q matrix, specifies the skills required by each item. Pooling all parameters together, the model can be interpreted as the chance for a student to fulfill a descriptor on the checklist depends on whether the student has the skills required by the descriptor as well as the descriptor's difficulty and power to differentiate. Q matrix specifies the relationship between test items or descriptor and the skills each item requires. Q matrix is central to all CDMs. The Q matrix adopted by the present study has 35 descriptors. They assess 5 subskills of writing. The vertical column lists all descriptors on the checklist. The rows lists the target writing skills to be assessed by each descriptor. Within the cells, we can specify which skills are needed for each descriptor. If a skill is needed, we put 1 in the cell, if not, we put a 0. The research answered 3 research questions, 2 of them are presented in this video. To what extent is the CDM approach useful for diagnosing academic writing? How do student diagnostic profiles change over time across the course? 10 instructors adopted a diagnostic checklist adapted from a prior research to mark 472 students' academic essays produced at the beginning, the midterm and the end of course. Each student produced 3 essays. Altogether, 1416 essays were produced by the 472 students, and they were marked by 10 raters. To monitor marking consistency across the 10 raters, a marking plan was implemented. Firstly, the essays were randomized and divided into 10 piles, 1 pile for each rater. 10 common essays were selected and inserted and mixed with the other essays in each pile. Therefore, the 10 common essays were marked by all 10 raters and linked their marking performance. In addition, 2 of the 10 raters served as expert raters. The 2 expert raters double-marked 27 essays randomly sampled from the other raters. The reduced RUM model was adopted to classify students into different learner profiles. As this example shows, the student named Julia was found to have this profile of 01101 at the beginning of the course. This profile indicates that Julia has mastered 3 skills, but she hasn't mastered 2 required sub-skills. All 472 students were profiled similarly as Julia for all 3 time points. The study found at time 1, the most frequent profile is the mastery profile of 11111, which represents 24% of students who were considered to have mastered all 5 skills. This figure is 31% at time 2, and 27% at time 3. In addition to the 2 flat profiles of 11111 and 00000, which show students who mastered all skills and the students who mastered none of the skills, a wide range of uneven profiles were also identified. Each profile shows its unique weaknesses. To further reveal the usefulness of CDM, the researchers selected 10 students from each performance level to examine their profiles. At each level, the students selected had the same raw scores as shown in the table. However, the CDM identified multiple different profiles at different levels. This finding suggested the CDM approach can identify problems or weaknesses that the traditional raw score approach can't. To track the changes of profiles across time, the researcher chose 4 groups of students, 2 strong groups with strong profiles and 2 with weak profiles. For the students with a master profile at T1, only 17.4% in this group stayed at this profile at T2. Quite alarmingly, 17% degraded to 0.0000. At T3, only 1/3 stayed at the mastery profile, the rest all had various decreases. For the 47 students with a weak non-mastery profile at time 1, this group transited to multiple profiles at time 2. Many improved substantially, including 46.8% jumped to the mastery profile and about 18% increased to mastery of 4 skills. At time 3, many students kept the benefits. For example, 32% stayed at the mastery profile, only about 15% stayed at the initial non-mastery flat profile. This group clearly benefited from this course. Comparing the changes of Profile 1 and Profile 4, we can observe that the numbers of their skill distribution became very similar at the end of the course. If we recall how different these 2 groups of students were at the beginning of the 13-week course, the results are rather striking. To sum up, these findings suggest that the initially weakest students benefited the most from the course, and many could keep the benefits until the end of the course. However, the initially strongest students did not seem to benefit from the course, only about 1/3 of them kept their master profile at the end. This research shows that employing a detailed checklist and a cognitive diagnostic modeling approach could enhance the accuracy of identifying diverse writing abilities and profiles based on multiple criteria. The CDM-generated learning profiles allow researchers to track profile changes at scale, providing insights into the developmental paths of second language writers. To conclude, the CDM approach to diagnostic assessment could yield valuable information to benefit students, teachers, and program administrators for program planning and evaluation.